For weeks, astronomers have tracked the strange interstellar object known as 3IATLAS, expecting nothing more than a mysterious visitor drifting through the solar system. But then the unimaginable happened. In a burst of brilliance, Atlas unleashed an intense beam of light, not into the endless void, but directly toward Mars. Was this a freak cosmic event or something far more deliberate? And if Atlas can aim at Mars, what happens when Earth is next? When space gets weird, most space rocks follow boring, predictable patterns when they visit our neighborhood. They heat up as they approach the sun, develop tails that point away from solar radiation, and their brightness changes follow nice mathematical curves that researchers can map out months ahead of time. 3IATLAS took one look at these expectations and decided to rewrite the entire playbook in ways that have left the global astronomy community scratching their heads and questioning everything. They thought they knew about how objects behave in space. From the moment telescopes locked onto this visitor, it started pulling stunts that should be physically impossible. Instead of gradually brightening as it moved closer to the sun, like every respectable comet in history, 3IATLAS began having what can only be described as cosmic temper tantrums. Its brightness would suddenly explode from barely visible at 18th magnitude to clearly detectable at 12th magnitude, then drop back down without any warning or scientific explanation that made sense. These aren't gentle changes that happen over weeks or months like normal comets exhibit. We're talking about dramatic shifts in luminosity that occur almost overnight, leaving professional astronomers staring at their data, wondering if their expensive instruments had suddenly broken. The object was producing light directly from its surface, rather than from the typical fuzzy envelope of gas and dust that surrounds most comets, which is roughly equivalent to finding a snowball that generates its own internal illumination. The astronomical community found themselves in the deeply uncomfortable position of having to consider explanations that sounded more like science fiction than peer-reviewed research. When highly respected scientists with decades of experience start quietly suggesting that maybe this object might not be following natural processes, you know something genuinely extraordinary is happening in our cosmic backyard. Early observations showed 3IATLAS maintaining what appeared to be a reddish surface color with a thin layer of material. But even these seemingly normal characteristics came packaged with their own set of puzzles that completely defied every conventional explanation anyone could think of. This thing decided physics rules don't apply. 3IATLAS has essentially become the rebellious teenager of space objects, flat out refusing to follow any of the established behavioral patterns that govern how comets and asteroids are supposed to act when they visit our solar system. The first major act of defiance came when it decided to change colors like some kind of cosmic mood ring, shifting from red to green as it moved closer to Mars in a transformation that happened way too quickly and at completely the wrong distance from the sun. For normal comets, color changes are gradual and predictable events that follow well-understood chemical processes as different materials heat up and begin evaporating in the vacuum of space. These transformations typically occur over extended periods and correspond directly to measurable changes in temperature and solar radiation exposure. 3IATLAS had apparently never read the manual on proper comet behavior because it executed this color shift in a time frame that matched no known natural processes. The brightness fluctuations became even more dramatic and inexplicable as 3IATLAS entered the asteroid belt region. These sudden explosive increases in luminosity don't correspond to any predictable heating patterns or documented chemical reactions that should be occurring at that particular distance from our sun. Most comets follow smooth mathematical curves as they brighten during their approach, allowing scientists to predict their appearance and behavior months or even years in advance with remarkable accuracy. 3IATLAS appears to be operating according to its own internal schedule that has absolutely nothing to do with external solar influences or gravitational effects. The brightness jumps happen at seemingly random intervals, creating a light curve that resembles a chaotic stock market graph rather than the smooth, predictable patterns that characterize natural celestial phenomena. Each unexpected outburst raises fundamental questions about what kind of energy-producing processes could be occurring inside or on the surface of this mysterious visitor. These erratic brightness patterns have forced astronomers worldwide to completely abandon their standard mathematical models for predicting comet behavior. Traditional calculations that work perfectly for literally every other known comet in our database produce wildly inaccurate results when applied to 3IATLAS. The object seems to be following a completely different set of physical principles, or perhaps operating according to some kind of internal logic that human science hasn't figured out yet. The unpredictability extends far beyond just brightness changes and color shifts. Every aspect of this object's behavior suggests it might belong to an entirely new category of interstellar visitor, one that doesn't fit into our carefully constructed classification systems for comets, asteroids, or space debris. Scientists are finding themselves forced to expand their fundamental definitions of what's actually possible when objects travel through the vacuum of space. Someone broke the light show rule. The most absolutely mind-boggling feature of 3IATLAS is something that violates everything humans know about how comets work in ways that should be physically impossible according to 4 billion years of documented solar system behavior. This object is shooting what appears to be a focused beam of light directly toward the sun, which is roughly equivalent to discovering water that flows uphill or fire that freezes instead of burning hot. Every single comet in recorded astronomical history has developed tails that point away from the sun because solar wind and radiation pressure naturally push all materials outward into space. This isn't some obscure technical detail that only specialists understand. It's one of the most basic and fundamental principles governing how matter behaves when exposed to stellar radiation. Comet tails always point away from the sun, like cosmic windsocks showing which direction the solar wind is blowing. 3IATLAS looked at 4 billion years of established physics and decided to do the exact opposite by creating what researchers are calling a forward-pointing light beam. Images from the Hubble Space Telescope clearly show this impossible structure stretching 10 times farther toward the sun than in any other direction, creating a cosmic lighthouse effect that has never been observed or documented in the history of space exploration. This isn't some subtle anomaly that requires advanced computer analysis to detect. It's a massive, obvious violation of basic principles that every astronomy student learns in their first semester. Scientists have desperately tried to explain this phenomenon using conventional physics, suggesting that unusually large chunks of solid material might be breaking away from the sun-facing side of 3IATLAS. These theoretical fragments would need to be heavy enough and durable enough to resist being pushed backward by the intense solar wind, instead somehow managing to float in front of the object while reflecting sunlight in completely unprecedented ways. This explanation requires 3IATLAS to be constructed from much more solid, stable material than typical comets, which are usually described as dirty snowballs held together by frozen water and various ices. The forward-pointing beam also exhibits characteristics that don't match any documented anti-tail formations that astronomers have observed before. Normal anti-tails are temporary optical illusions caused by specific viewing angles and dust particle alignment when Earth, a comet, and the Sun line up in particular geometric relationships. These effects are relatively faint, short-lived phenomena that last only briefly before dissipating. The precision extends far beyond just the general trajectory and encompasses the object's timing and positioning during absolutely critical phases of its cosmic journey. When 3IATLAS reaches its closest approach to the Sun, called perihelion in astronomical terminology, it will be positioned exactly behind our star from Earth's perspective, making it completely invisible to our most powerful ground-based telescopes and space-based observatories. The Sun's overwhelming electromagnetic radiation and brilliant visible light will effectively block any attempt to observe what this mysterious object might be doing during this absolutely crucial phase of its visit when it has maximum access to enormous amounts of solar energy. If someone were deliberately designing a reconnaissance mission specifically intended to study our solar system while simultaneously avoiding detection by Earth-based civilizations, this would represent absolutely textbook strategy and near-perfect execution. Hiding behind the Sun provides complete concealment from all Earth-based instruments while simultaneously offering access to virtually unlimited amounts of energy that could theoretically power advanced technological systems, recharge depleted power sources, or fuel whatever exotic processes this object might be designed to perform. Mars gets the best seat in the house. October 3rd, 2025, represents what might be the single most important date in the entire 3IATLAS investigation and possibly one of the most significant observational opportunities in the history of interstellar object research. On that specific date, this completely enigmatic visitor will make its closest approach to Mars, providing the international scientific community with what could very well be their only realistic opportunity to definitively determine what they're actually looking at and whether it represents natural or artificial phenomena. NASA's Mars Reconnaissance Orbiter, equipped with the incredibly sophisticated high-resolution imaging science experiment camera system, is being strategically repositioned and carefully programmed to capture what will hopefully be the highest resolution images ever taken of any confirmed interstellar object. This advanced imaging system possesses the remarkable capability to resolve surface details as small as 30 km per pixel, which, while not quite sharp enough to reveal fine textural features or small-scale structures, should definitely provide absolutely crucial information about 3IATLAS's overall structural composition and light-producing mechanisms. Most importantly, from a scientific perspective, these unprecedented observations could finally provide a definitive answer to the central question of whether this mysterious object actually generates its own internal illumination through unknown processes, or whether it simply reflects incoming solar radiation in completely extraordinary ways that nobody currently understands. This single critical observation could potentially determine once and for all whether researchers are dealing with exotic but natural phenomena or something that might require entirely new theoretical frameworks to explain. This imaging opportunity represents an absolutely historic first achievement in the field of astronomical observation and interstellar object research. Never before in human history has any confirmed interstellar visitor been photographed from the perspective of another planet in our solar system. Every single previous image of Oumuamua, 2I Borisov, and 3IATLAS has been captured exclusively from Earth-based telescopes or various satellites and space observatories orbiting our home planet. The unique Martian perspective could potentially reveal crucial structural details, behavioral patterns, and physical characteristics that remain completely impossible to detect or analyze from Earth's viewpoint due to distance, atmospheric interference, and viewing angle limitations. Multiple spacecraft positioned at different locations throughout the solar system may contribute valuable data to this unprecedented international observation campaign. The timing of this observation opportunity becomes particularly critical and urgent because 3IATLAS won't remain accessible for detailed study much longer. As a genuine interstellar object, it isn't gravitationally bound to our solar system like comets and asteroids that originate locally, and it will eventually continue its journey into deep interstellar space, quite possibly never to return within any reasonable human time frame. Unlike periodic comets that can be studied repeatedly over multiple orbital approaches spanning decades or centuries, interstellar visitors offer researchers exactly one chance to gather comprehensive scientific data before they disappear forever into the cosmic void. That's it for today. What do you think is happening with this mystery? Let us know your thoughts in the comments down below. Don't forget to like and subscribe. The structure emanating from 3IATLAS is far more intense, much longer lasting, and extends vastly farther than any previously catalogued anti-tail formation. The intensity and focused nature of this light beam suggests either completely unknown physics operating in our solar system or the involvement of artificial construction and control mechanisms. Natural processes in space typically create diffuse, scattered light patterns rather than concentrated directional beams that maintain their focus across vast distances. The precision and remarkable stability of this forward-pointing structure strongly implies some kind of organizing force that actively maintains the light's focus, rather than allowing it to spread randomly in all directions like normal reflected sunlight should. Mixing up the space recipe, the chemical composition of 3IATLAS reads exactly like someone took a random selection of elements and mixed them together in a cosmic laboratory without bothering to consult basic chemistry textbooks or the periodic table. When scientists used advanced spectroscopic analysis to examine the gases and materials surrounding this object, they discovered a combination that fundamentally violates basic principles governing how materials naturally form and exist together in space environments. The breakdown shows 87% carbon dioxide, 9% carbon monoxide, and only 4% water, which is essentially like discovering a fish that's constructed primarily from feathers and concrete instead of normal biological materials. This chemical signature represents a complete inversion of every known type of space object that humans have ever studied or documented. Comets are supposed to be primarily composed of water ice mixed with various rocky and dusty material, earning them the scientific nickname dirty snowballs due to their typical composition. Finding something that consists almost entirely of carbon dioxide gas with minimal water content is equivalent to discovering an iceberg made entirely of sand and metal instead of frozen water. It simply doesn't correspond to any existing category in our comprehensive classification systems for natural space objects. The James Webb Space Telescope's detailed chemical analysis revealed this impossible composition, along with traces of additional exotic materials that shouldn't exist together under normal circumstances. The presence of significant amounts of nickel without any corresponding iron deposits creates another chemical impossibility that defies everything scientists understand about cosmic material formation. In space environments, these two metals almost always occur together because they form under nearly identical conditions and possess remarkably similar chemical and physical properties. They're like cosmic twins that naturally refuse to be separated under any known circumstances found throughout the universe. Finding isolated nickel deposits suggests that 3I-ATLAS either formed in an environment completely unlike anything that exists in our solar system or anywhere else humans have studied. Or alternatively, it might be composed of artificially manufactured materials that simply don't occur through natural stellar processes. The carbon monoxide component adds yet another impossible layer to this already inexplicable chemical puzzle. While carbon monoxide does exist naturally in various cosmic environments, discovering it in such extraordinarily high concentrations, alongside carbon dioxide and isolated nickel, creates a signature that doesn't match any documented stellar formation process or known chemical reaction that occurs in space. It's essentially like finding a signature written in a completely unknown language using ink manufactured from materials that shouldn't exist in the same location at the same time. Harvard guy thinks we found space visitors. When Harvard astronomer Avi Loeb starts publicly suggesting that a mysterious space object might actually be artificial technology rather than a natural phenomenon, the entire global scientific community pays very close attention whether they feel comfortable with his conclusions or not. Loeb has built an impressive professional reputation over decades for asking the kinds of uncomfortable questions that most researchers typically prefer to avoid discussing in polite academic circles. And his detailed analysis of 3I-ATLAS raises possibilities that sound like science fiction, but come backed by serious scientific credentials. Loeb's hypothesis centers around the idea that 3I-ATLAS might be operating as some kind of technological mothership specifically designed to release smaller reconnaissance probes while passing through our solar system on what could be an intelligence-gathering mission. According to his careful analysis of the observational data, the sudden dramatic brightness increases could represent a sophisticated technological object systematically breaking apart and deploying smaller reconnaissance craft toward Mars, operating in a manner remarkably similar to how human spacecraft routinely release satellites or specialized landing modules during complex space missions. The timing of these brightness bursts becomes particularly intriguing when you consider that they seem to occur with suspicious precision, especially as the object approaches Mars rather than following the random patterns you would expect from natural chemical processes. This apparent coordination seems far too precisely orchestrated to represent mere natural coincidence or the chaotic results of random chemical reactions occurring inside a typical comet nucleus. The spacecraft theory attempts to provide a comprehensive framework for explaining literally all the impossible behaviors that 3I-ATLAS has demonstrated since its discovery. The forward-pointing light beam could represent some form of advanced propulsion system, or perhaps a sophisticated communication device transmitting signals back toward its point of origin. The completely bizarre chemical composition could indicate the use of artificial construction materials that don't exist anywhere in nature or in any known stellar formation processes. Loeb originally became interested in 3I-ATLAS when astronomers discovered what appeared to be a related object called C2025F2. Also known as Comet Swan, which initially seemed to be traveling from the same general cosmic direction. Early orbital calculations suggested this newly discovered comet might actually be a fragment or deployed probe that had been released by 3I-ATLAS during its passage near Mars, potentially providing concrete evidence supporting the mothership hypothesis that Loeb had proposed. Flying through space like it planned the route, the trajectory that 3I-ATLAS is following through our solar system demonstrates such remarkable precision and strategic planning that it's forcing seasoned professional astronomers to seriously question whether they're observing advanced technological navigation rather than the random wandering typical of natural space objects. This visitor is maintaining a path that runs almost perfectly parallel to the flat orbital plane where all our planets travel. which represents a level of precision roughly equivalent to threading a needle while blindfolded from distances measured in millions of miles. The statistical probability of any random interstellar visitor naturally achieving this degree of navigational accuracy is so astronomically low that scientists are genuinely struggling to explain it using conventional natural processes or known gravitational mechanics. Most objects that approach our solar system from interstellar space arrive at chaotic angles and follow unpredictable paths that reflect their random origins and the various gravitational influences they encountered during their long journeys through the cosmic void. What makes this trajectory even more suspicious and indicative of possible intelligent control is how 3IATLAS appears to be making what can only be described as strategic decisions regarding planetary encounters during its journey. The object passes sufficiently close to Mars to enable detailed scientific observations and potentially allow for sample collection missions. Yet it maintains a carefully calculated distance from Earth that avoids any possibility of collision or extremely close approach that might trigger defensive responses or more intensive study protocols. This highly selective approach to planetary flybys feels much more like the result of intelligent mission planning and deliberate route selection rather than the chaotic, gravitational interactions that typically govern how natural space objects behave when they encounter planetary systems.